All right, I know that you've had a spectacular time doing all the integrations with the trig functions, but we're going to leave those for a little bit. What we're going to do today is algebra. So you're trading trig for algebra. And you're going to do something called partial fraction decomposition. It sounds really cool, and it is really cool. It also sounds really great if you can just drop that like a dinner conversation. You know, I did some partial fraction decomposition. But it's one of my, I think it's fun, but then, you know, I would. Let me kind of show you the PowerPoint and we'll kind of talk our way through it to kind of show you the rationale for it and those kind of things. So let me kind of get back up here to the beginning of this PowerPoint rather than the end. Okay. So it is called partial fractions. Now, let me kind of show you. You're accustomed to taking like numerical fractions and adding them or subtracting them. All right, so, and then you went from there to algebra where you took algebraic fractions and added or subtracting them. So this is more what you're accustomed to doing, taking two fractions, whether they're numerical or algebraic, and then adding them and getting one fraction. What we're going to do is we're going to reverse that process. So instead of starting with the separate fractions and then end up with one fraction, you're going to start with one fraction and break it into parts. So that's why it's called decomposition. Decompose means break into parts. So you're reversing the process. So in other words, what you would do, whoop, went too fast, what you would do is you would take what you think of kind of as the answer and break it up into the problem. Okay? So let me kind of show you why you might want to do that sometime. Suppose this was the integration that you had. Now, that one basically, let me kind of get rid of this maybe on a good day. Okay, this one is a fraction. So the first thing I would try to think of is, well, maybe it's natural log. Well, look at this denominator. The derivative of that is 2x plus 1. And I've got 3x plus 14. So just by multiplying that numerator by something and then multiplying out here by the multiplicative inverse, I can't get 2x plus 1. So natural log really isn't going to work. Now what I could do is I could break it up and put 3x over that denominator and then do 14 over that denominator, but that's not going to be very, very good either. So I said this, wouldn't it be nice if you knew that you could break that fraction up into 4 over x minus 2 plus negative 1 over x plus 3, because if these two fractions added together are the same as that fraction, you could just replace this one with this two and then break the integration up. Because look how easy that would be. You could, you know, this one is a fraction. Well, what's the derivative of the bottom? 1. Well, there's an easy way to get 1, just pull the 4 out. In the same way here, the derivative of that denominator is 1. Well, the easiest way to get it is to pull the negative 1 out. So I've just got like natural log of this one, and I've got natural log of that one. And then again, that 4 comes down, and then plus the negative is the same thing as minus. So if I knew that this one fraction was the sum of those fractions, this one would be a super easy integration to do. So that's what we're going to learn to do in this video. We're going really to learn to do algebra. Now, supposedly you learn to do this in like an Algebra 2 class or a pre-calculus class. But I have found through the years that a lot of times when students get to my class, they either have never seen this or don't remember how to do it. So what I want you to understand is this. We're going to spend the majority of this video learning to do this part right here, which is really just Algebra 2, okay? Now, I don't want you to be intimidated by the steps, because what I tried to do, I tried to write down every little nitpicking thing that you do, and there's like 13 steps. So when we start the next video, if it were me, I would freeze it, and I would write these steps in my notes. And then I'd go to the next slide and freeze the video and have those steps in my notes. And then that way I'd have all 13 steps beside me when we started the first example in a minute. So I'm going to kind of talk you through this, but it's not probably going to make a whole lot of sense until you see me do it. Now, step 1, I don't think I do one that uses step 1 because we've done this in class before. But anytime you've got a rational function, you know, that's a polynomial over another polynomial, the first thing you should do is notice the degrees. If the power in the numerator is higher than the power in the denominator, or the same, the first thing you should do is long division. And then relook at your integrand and see what you need to do. But don't forget to do that. If the power on the top is higher or equal to the power on the denominator, do long division first and then reevaluate your situation. Okay? So if you decide that you want to do partial fraction decomposition, the first thing you're going to do is you're going to completely factor the denominator. Now, what I mean by completely factor, the first thing you do is look for common terms that you can pull out. Then if it's the difference of perfect squares or a quadratic, I mean, you know how to factor. You've done that since like 7th grade. So just make sure that you factor it all the way down till you can't factor it anymore. Now, if each of the factors in your denominator is linear, now what do I mean by linear? No power on a variable greater than 1. Okay, we'll talk about that in a minute. Okay, then what you're going to do is you're going to separate the denominator factors. You're going to put a single capital letter over each of those linear factors. Okay. Then to the side, you're going to go and you're going to write the original integrand equal to the new integrand. Then you're going to find a common denominator on the right side, and you're going to change it into a single fraction. So it looks like you're kind of undoing what you just did, but you'll see in a minute why that's helpful. So you're going to have two fractions now equal to each other, and the bottoms, the denominators, are going to be equal. Well, now think about it. If you've got two fractions and the bottoms match, that forces the tops to match. So all you got to worry about now is putting this numerator equal to this numerator. So that's what you're going to kind of do in step 6. So you're going to have an equation. So what you're going to do is you're going to work with the right side. You're going to multiply the right side of the equation out. You're going to group like terms. You're going to factor out the things that are alike. And then you're going to have the coefficient on the left equal to the coefficient on the right. So you're going to take the coefficient of x squared on the left side and set it equal to coefficient of x squared on the right side. You're going to take the coefficient of your linear term on the left and set it equal to the coefficient of your linear term on the right. You're going to take the constant on the left and set it equal to the constant on the right. And when you do that, you're going to have a system of equations like you had in Algebra 1 or 2, and you're going to solve the system. So, you try to make either the X's or the Y's, so to speak, the A's or the B's, opposites of each other, so that when you add the equations, one of those variables goes out. And so you solve for a variable, then you substitute back to get your others. Then you now have solved for those capital letters, and you put them back in the integrand, and you work the problem. Now, what does any of that mean? Okay. Make sure that you've frozen the video and you have these 13 steps next to you so you can look at the steps and then look at the screen. All right, hopefully you're back and you've got your steps next to you. Look at this one. Now notice, natural law, the derivative of that denominator is 6x minus 2. All right, now I can't turn this into 6x minus 2. I always double check. The power on the top is a 1, the power on the bottom is a 2, so I don't need to do long division. So long division is unnecessary. So look what your second step says to do. It says to factor completely that denominator. So if you factor 3x squared minus 2x minus 1, it factors into 3x plus 1, and then times the quantity x minus 1. Then step 3 says, okay, if you've got linear factors, see the power on the variable here is 1, the power on the variable here is 1. This is a linear factor and this is a linear factor. So it tells you to put a single capital letter over both of those linear factors. Okay, so I'm going to break this one integrand into the sum of these two integrands. Now the rest of the work is to really try to figure out what A equals and what B equals. So what I'm going to do now on step 4 is I'm going to kind of go to the side and I'm going to play algebra. And then I'm going to come back after I play algebra and substitute in my number for A and my number for B and then finish the calculus. All right, so let's go look at it. Now, here's what we're going to do. We've got this. I just recopied it from the previous page. And I'll leave it and just look at this integrand right here equal to this integrand. Now, step 5 says that you work on the right side. So I need a single fraction. So what's the common denominator between 3x plus 1 and x minus 1? Well, that common denominator is 3x1 times x minus 1. So I'm going to change the sum of these fractions to a single fraction. Like you do with numbers, we've kind of done this before a little bit in class. Remember what you do. What do you multiply 3x plus 1 by to get 3x plus 1 times x minus 1? Well, in order to do that, I'm going to make sure I get my little notator here. All right. To get from here to here, to get from here to here, you must have multiplied this denominator by x minus 1. So I've got to take this old numerator and multiply by x minus 1. And then plus. And then what'd you multiply x minus 1 by to get this denominator? Well, I must multiply this one by 3x plus 1. So I've got to take my old numerator b and multiply by 3x plus 1. So that's what step 5 means. So now I've just got this new fraction. Now notice, this is the same thing as this denominator. All right, this is just factored form. If you multiply this denominator up, you're going to get 3x squared minus 2x minus 1. So this fraction is equal to this fraction. So if those denominators match, then that forces those numerators to match. Okay, so now all I've got to do is I'm going to go work with my numerator. Okay, so this is just kind of recopied from the previous screen so that you can kind of follow it still. Okay, the fractions matched, the bottoms match, so the tops match. So all I'm going to worry about is this numerator, 3x minus 1, equal to this numerator. And again, I'm going to stay on the right side. I multiply it out. A times x is ax, minus, and then a times 1 is a, plus, and then b times 3x is 3bx, plus, and then b times 1 is b. Then I group like terms together. I mean, this thing right here has an x in it, and this thing right here has an x in it. So that's what I mean by I grouped those like terms together. This thing right here doesn't have any x's in it. All right, and this thing right here doesn't have any x's in it. But notice it's a minus a and a plus b. So I grouped them together. So these are kind of my x terms, and these are my constants. Then it says in step 9 to factor out what's the same. So both of these have an x, so I factored the x out. Now, the reason I put the x behind it instead of in front of it is this thing is really the coefficient of x, and you're accustomed to coefficients being in the front. So a plus 3b stands for a number in front of x. And then negative a plus b, all that is just one number like 7 or 2/3 or whatever. Now notice, all I did here was I brought this straight down and I just kind of changed the order. 3 minus x is the same thing as a negative x plus 3. And then I just made that negative x visible like a negative 1 because I wanted you to look at the coefficient. So what I did was I took the coefficient of x right here, this red one, and the coefficient of x right here, and I set them equal to each other. I mean, if these are the same, then the x's here have to match the x's here. So that's what equation 1 is. Okay? Then I went back and I took the constants. Okay? Let me clear my drawing so it's kind of easier to follow. So I took this constant of 3 and set it equal to this constant, negative a plus b. So this is my system of equations from my coefficient of my x's. The blue one's my system, my equation with my constants. Now I need either the a's to be opposites or the b's to be opposites. Now I got lucky because the a's were already opposites. Sometimes you have to multiply by a number. We'll do one of those in a minute in order to get them to be opposites. But this, you should know how to solve a system. So a plus a negative a goes out and leaves me 3b plus b is 4b. And then, of course, a negative 1 plus 3 is a 2. So step 11 says to solve this system for a variable. Well, if 4b is 2, then b's got to be a half. So I've got my answer for b. I already know what to put in for b. How do I get a? Substitute back into either of these equations. Now, why did I substitute into this one? Just because it looked easier to me. So the opposite of a plus b is 3. Well, I know b is a 1/2, so I put a 1/2 in there. I subtract 1/2 from both sides, and that's where I got a negative a was 5/2. And then I divided both sides by the negative. So now I've got my a and I've got my b. All right, so all of this was just algebra. Now I'm ready to go back and do some calculus. Okay, so I'm going to go back. Let me clear this so it doesn't bother you when we go back up in a minute, hopefully. Okay, Clear it? Now let's go back to the calculus. Okay. Now I'm going to substitute in my -5 halves for A, and I'm going to substitute in my 1/2 for B. So my -5 halves went back in place of A, and my 1/2 went back in place of B. So I did all that algebra to figure out what number A was and what number B was equal to. Well, then look, this is simple. What's the derivative of that denominator? 3. Well, what's the easiest way to get a 3 here? Well, first of all, I'd probably pull the -5 halves out, so I don't have to worry about it. And the same thing here, I'd pull the 1/2 out. What do you multiply 1 by to get 3? Well, 3. Okay, so what I need to do right here is I really need to come up here, all right, because I didn't finish this. I thought I did, but I didn't, so let's go fix it. Okay, so let's go do this. I need to multiply this numerator by 3. So what do I need to multiply out here by? That's right, I need to multiply by a 1/3. All right, so we can fix that. You fix that on your paper. Now again, what's the derivative of that denominator? It's a 1, and I've already got a 1, so that one's okay. So right here, 1 times a -5 is a -5, but 3 times 2, that denominator right there really needs to be a 6. That's easy to fix. Okay, so you've got something on the bottom, you've got its derivative on the top, so that's just natural log. You've got something on the bottom and its derivative on the top, so it's just natural log. So it's really, I mean, think of it kind of like a game. It really is fun. All right, you're just going to go, you're going to leave your calculus, go play some algebra, and then come back and do your calculus. Okay, let's go look at one more just to make sure that everybody's okay. I feel sure that you are, but it just makes me feel better. Okay. All right, so let's go do one more. All right, let me go share the screen again. Okay, come back. Here we go with example 2. Okay, now look at this one. All right, this one's not any harder, but the system of equations is a little longer. That's why I'm doing it. All right, again, the derivative of that denominator is 3x squared minus 4, and I've got a 12x. I'm just stuck. I do double check. The power on the top is not higher than the power on the bottom, so I don't have to do long division. So the first thing I'm going to do is go factor that. Well, when you're factoring, the first thing you do is pull out a common term. So when I pull out x, that's going to leave x squared minus 4. Now this is what I mean by completely factor. If you stopped here, you wouldn't be finished. That's not completely factored. That's the difference of perfect squares. So make sure that you fully factor that denominator. Now, each of these terms is linear. They're not like an x squared or an x to the 4th power. So you put single capital letters over each one. So a capital letter over an x, plus a capital letter over the x minus 2, plus a capital letter over the x plus 2. Now, as far as what capital letters, if K is your favorite, put a K. The book just goes in alphabetical order, but it's nothing magical. Now, what you're going to do next is you're going to leave this. This is what you're going to do to the side. You're going to go play algebra. You're going to take the integrand here and set it equal to the integrand here. Then step 5 says to get a common denominator on the right side. So your common denominator is x times x minus 2 times x plus 2. Well, now, just like before, what'd you multiply x by to get this thing? Do you see that there's an x minus 2 and an x plus 2 that's new? So you take your old numerator x and multiply by those two things. And then plus, so I put a plus. What'd you multiply x minus 2 by to get that? What's new? Well, that x and that x plus 2. So you take your old numerator b and multiply by that x and that x plus 2. What'd you multiply x plus 2 by to get x times x minus 2 times x plus 2? Well, you multiplied by x times x minus 2, so you take your old numerator c and multiply by those same two things. Now remember what we said, this fraction here is equal to this fraction, and this denominator matches that one. If you multiply that one up, you just get x cubed minus 4. So if the fractions are equivalent and the denominators match, then the numerators match. So all I've got to do is worry about this numerator equal to that one. And all I did was I went and multiplied this numerator up. So I multiplied x minus 2 times x plus 2 to get the x squared minus 4. I multiplied x by x plus 2 to get that. I multiplied x by x minus 2 to get that. Then I distributed the c here, and the b there, and the a there. So I get an ax squared minus a 4a, plus a bx squared plus a 2x times b is 2bx, and a c times an x squared is a cx squared minus, and then a c times a 2x is a 2cx. Now I'm going to go basically play with this in the next slide. I'm just going to keep going and continue. Okay? So remember what you do. The next thing you do is you're going to group like terms. Okay? So notice, this has an x squared, and this one has an x squared, and this one has an x squared. So I put the three of them together. And then plus, always a plus. That doesn't have an x. And, all right, so it's grouped by itself over here. And then look, this one has an x in it, and this one has an x in it. So I grouped the 2bx and then a minus 2cx. So these are the x's, and then this is the one without an x. It's my constant. So I grouped my x squareds, my x's, and my numbers, my no x's. So then I factored out what's common. I factored the x squareds out. So do you understand that this red thing is my coefficient of my x squared? Okay. This black thing is the coefficient of my x's, and then this thing is my constant. I don't have any x's. Well, now how do I get my system of equations? I set the coefficients here equal to the coefficients here. Here's the coefficient of x squared on the right, and there's the coefficient of x squared on the left. So equation 1 is the coefficient of x squared equals the coefficient of x squared. Now go to the linear factors. The coefficient of your x's is 2b minus 2c. The coefficient of your x's over here is the 12. All right, so that's where I got equation 2, the coefficients of my x's. Then I set the numbers equal. This is just a number, it doesn't have any x's, and that's just a number, it doesn't have any x's. So I set them equal to each other. Now, instead of having a system of 2 equations, I've got a system of 3 equations. But see, this one I can already work. If a negative 4a is 12, if I divide both sides by a negative 4, I get a is negative 3. So now I already know that a is negative 3. So I can put that back in equation 1 and make it look a little better, and put it in equation 2 and make it look a little better. So that's what I did. When I plug this negative 3 in for a up here, all right, a plus b, all right, when I put it in all the way over here for my a, I've got b plus c left, and I have a negative 3. Now, when I move it over, it's a positive 3. Remember, I'm really adding 3 to both sides, and 1 plus 3 is 4. So this red equation right here is it's my old equation 1 after I substitute in negative 3 in place of a and simplify. Do the same thing on this one. Plug in that negative 3, all right? And then here I've got a 2b minus 2c is 12. There's no a to plug into there. So I keep that one the same. But now I've got 2 equations in b's and c's. Now again, I need to make them match. I can either make the b's opposites or the c's opposites. I decided it'd be easier to make the c's opposites. So I multiplied everything here by 2. So that gets multiplied by 2, that gets multiplied by 2, and that gets multiplied by 2. It's hard to kind of do with this little writer. So 2 times b is 2b, plus 2 times c is 2c, equals 2 times 4 is 8. So I just multiplied straight across by 2. Then I add them. Well, see, the c's go out, and 2b plus 2b is 4b, 8 plus 12 is 20, so 4b is 20, so b is 5. So now I know that a is negative 3 and b is 5. So I can plug into any of these equations and see what c is. So I plugged into my b for 5 there, and I solved and found out that c was a negative 1. So now I've got my a is a negative 3, my b is 5, and my c is a negative 1. So every time you get one variable solved, you substitute in and simplify, and then keep doing it till you get all the variables. So I'm going to now go back to my calculus. I'm going to replace that a with a negative 3, that b with 5, and that c with a negative 1. Okay, so let me clear these drawings, and then let me go back to that next screen so that you can see the actual calculus. So remember, A was a -3, B was 5, and C was a -1. So I just put -3 in place of A and 5 in place of B and -1 in place of C. Now, we keep getting a lot of natural logs, but now we'll see on the next video, sometimes you get different things like arctan, okay? But so far, so good. The derivative of that bottom's a 1, so the easiest thing is to pull that -3 out. So I'm just breaking it up into 3 different integrations. The derivative of that denominator is 1. The easiest way to get a 1 there is just to pull out the 5. The derivative of that's a +1, so the easiest way to do that is to pull out that -1. So I've got this -3, I've got the natural log of the absolute value of that bottom. I've got 5 in the natural log of that denominator, and then I've got a -1 in the natural log of that denominator. Now, plus the -1, you know, is the same thing as minus. Okay? So they're not hard, they're a little long, but I think they're fun. Okay? So basically what I would do if it were me is I would have my steps out, but don't complicate something that's not complicated. If it's natural log to start with, do it. If you can break it up and put this one over the first and that one, and you can go back, remember what we said, you're going to go from the first things you learned down to the last things you learned. But always double check that power in that numerator, because if it's the same or greater than the power of the denominator, you need to use long division first before you do anything else. Okay? But so you understand with linear factors what you do. Capital letters over each linear factor. Then you leave the calculus and you go over on the side and you start playing algebra. You set the old integrand equal to the new integrand. Then you keep working with the right side. Okay? So you're going to keep getting a common denominator. Then you're going to set the numerator over here equal to the numerator over here. Multiply it out, group like terms, get yourself a system of equations and solve that system. Now, the next video, we'll talk about what happens when you have nonlinear factors, which are going to be quadratics, okay? But not this time. So your first set of homework is going to be just with linear factors. And again, if you're having any trouble, I need you to email me so we can get some help.